Now, as you can see here, we pointed out here in matrix A that this is actually a multiple of -2 of column 1. In doing so and performing the column operations, we had an entire column of zeros. Hence, using cofactor expansion here, we had a 0 as our determinant. Now, this is one of the cases wherein we can immediately detect if the determinant is 0. So, there are 3 conditions that yield a 0 determinant. If A is a square matrix of and any one of the following conditions is true, then the determinant is 0. So first, if you have an entire row or an entire column consisting of zeros, like what we had a while ago, or 2 rows or columns are equal, they have exactly the same entries, or not the first one, but the third one is what we have. One row or column is a multiple of another row or column. So here, this is a multiple of this column. Column 2 was a multiple of column 1. So if that is the case, then we were sure to get a 0 determinant here. Now, this is to check if our square matrix would have this, then we don't need to compute. We just need to show that these are true, one of them. Then we'll have a 0 determinant. Try them with these matrices. Try to see if one of the conditions will fit to show that these matrices would have a 0 determinant. Now, let's start with matrix A. So, define the determinant of matrix A. That is the determinant of this matrix. Oops, yeah, correct. 18, 4. Now, at first glance, it looks like, sir, there's no row or column that would fit all or at least one of the 3 conditions that would yield our 0 determinant. If that is the case, then we can just perform our row operations, column operations, or do factor expansion, or, well, just perform the alternative method to find the matrix of this one. Let's perform an elementary row operation. Since this is already 0, I can make this 0 and then later on this is 0 as well. So, performing my row operation, since this is 1 already, that's another reason why we wanted to perform a row operation, because this is 1 already. So, we'll have row 2, I'll change this to 0, would be -2 times row 1 plus row 2. The determinant will just be the same, there will be no changes. That's a pretty long line, let's make it simpler here. There you go. So row 1 will remain the same. Row 2, -2 times 1 is -2, plus 2 is 0. -2 times 4, -2 times 4 is -8, plus 1 is -9. Plus -1 rather, is -9. -2 times 1 is -2, plus 0 is -2. Then we copy 0, 18, 4. Let's fix that 1 there. Now, as you can actually see, after performing one row operation, which will just give us an equivalent determinant, these rows rather, this row and this row have become, one is a multiple of the other. This row, row 3, has become a multiple of row 2. Because if we just multiply -2 to row 2, we get row 4. So after performing a row operation, we get a condition that makes the determinant 0. And since these are still equivalent determinants, therefore we can say that one condition is met for the determinant of A to be 0. And that is row 2 is a multiple of row 3. Therefore, the determinant of A is 0. How about in matrix B? In matrix B, let's write that down. Here, matrix B, the determinant of that would be determinant of this matrix here. Now, here it's actually easier because the determinant, or rather the row 1 and row 3, as we can see, are related. If we multiply -3 to row 1, we get row 3. In other words, let's just bring that down. Row 3 is a multiple of row 1. So therefore, the determinant of B is 0 as well. That's how we find that, and that's how we find conditions that would yield to 0 determinants.